Hey guys, I'm gonna move on to doing some notes for chapter 17. Okay, so chapter 17 is new material and it's our first chapter on hypothesis testing. So it is on hypothesis testing for proportions. So your book does all things proportions first. Okay, so we're going to do hypothesis testing on proportions before we move on to means. Okay, so I feel like people tend to think hypothesis testing is a tricky part of Unit 3. However, the general idea is that we have information about something and we really want to test if it's true. So we have information about something and we want to test if it's true. That's like the general idea about a hypothesis test. So we make hypotheses and we test if we have enough evidence to show that there has been a change. So we create hypotheses, plural, we make two, okay? And we test if there is evidence to show change. So we're just trying to show a change of some kind, okay? So I'm just going to jump right into the steps of running a hypothesis test. So you can see how we would try to test to show this evidence of change. All right. So the first step is that we have to state the hypotheses. Okay. And there are two hypotheses. Okay. The first looks like this, H sub 0. And I call that H naught because that is like a nautical zero. Okay. And it is referring to what we call the null hypothesis. Okay, and the null hypothesis stands for, so null means nothing, so this stands for that nothing has changed. Okay, so the null hypothesis in terms of a test on proportions always relates back to the population proportion. So for us, this looks like this, H naught colon, and then we say P, the population proportion, is equal to, and this is going to throw you off, but P sub 0. And we literally put in the population proportion. So whatever we know about the population value goes here, okay? And this is the letter P, so it's just notation, okay? So they all start like this, P equals, and then this is a number, okay? So it's some decimal for the sake of proportions, right? Because proportions are always smaller than 1, okay? So we would just use this notation to represent the null hypothesis or what we are told about the population, okay? And then we write what's called the alternative hypothesis. And this is what we attempt to show, okay? So the alternative hypothesis says something has changed. And that's very general, right? Something has changed. So we either say that it's bigger, smaller, or different. So it's bigger, smaller, or we just say it's different. Okay? And the way that we note this, using the same notation as above, is we would put, this is the alternative hypothesis, and then we have three options. We have P is greater than or bigger than the population proportion. We could write that P is less than, so it got smaller than the population proportion. Or if we're not sure, we can actually test that P is just not equal to the population proportion. So in the context of the problem, we're actually usually given information to make this choice, okay? So the problem is asking, do we think our sample is actually greater than what the population said? Or we're not sure, we just think something has changed. So there's always some kind of language in the problem that helps us determine which sign is on our alternative hypothesis, okay? But this is referred to as a right-tailed test. This one is referred to, I don't know why I'm writing right twice, as a left-tailed test, because in the pictures, the value lies on the right-hand side if it's greater, or on the left-hand side if it's less. And then this is actually referred to as a two-tailed test, okay? What that means is when we do the work inside the calculator, we actually convert our population and sample proportion into a z-score, and we graph it. And if the value is greater, it lies on the right-hand side of 0. If it's less, it lies on the left-hand side of 0. And if we're not sure, we actually graph two z-scores on either side. So once we state the hypotheses, right, we would calculate the test statistic and p-value, okay? And the best part about this class, which most of you already know based on experience, is that we actually do not do this work by hand. However, I want to show you that this is the z-score formula, okay? So the z-score formula takes our sample proportion, subtracts the population proportion, and then divides by the standard deviation from the estimate, which is actually using the population proportion. So this is how our z-score is calculated if we were ever to do that by hand. However, we use our calculator to find this answer, okay? So what happens is we do something that's referred to as a one proportion or one prop in your calculator z-test, okay? And we give our calculator the input of, just like for a confidence interval, we needed to put in x and n. This time we give our calculator p naught, so we have to tell the calculator the hypothesized value. We also have to say how many yeses, how many people were surveyed, right? And then we also have to give the direction of the alternative, okay? Which means that I have to select either greater than, less than, or not equal to. And the selection is based on exactly what is written right here on paper. If I write greater than, then in the calculator, I would select the symbol that says greater than, okay? And then the output is a z-score, and we also get what's referred to as a p-value, which is the shaded region in the picture I'm about to draw. So if this were a left-tailed, let's say we're testing p is less than p naught, okay? Then I might get a z-score somewhere over here, and my test is left-tailed, so the calculator would shade this region. And the shaded region would be referred to as the p-value, okay? And the calculator will tell me what that p-value is, all right? So we calculate our statistic and our p-value, which means we put all the information we need into our calculator. And then once we have that, we state the conclusion of the test, okay? So we can state our conclusion, okay? So the first thing we have to do before we can state our conclusion is figure out what our significance level for the test was, okay? So we first must know, and it has two names, okay? It's either called the significance level, or it's referred to as the alpha level, which looks like this. It's like, this is alpha in Greek. It looks like a little Jesus fish, okay? So we must know the significance level or alpha level. All right? So this is either provided in the problem, or we literally take 1 and subtract the confidence level, and we get the alpha level. Okay? So if our confidence level is 95%, then we would say 1 minus 0.95, and alpha would be 0.05. These are very small numbers. Okay? And then our final step, which I'll move on to another sheet of paper for this, is that we must compare directly. In order to make the conclusion, we compare your p-value to the alpha or significance level. Okay, and I will move on to another sheet, so this is super clear. Let me just grab an extra sheet of paper. All right, so I'm going to scoot this over. Right now, we have a z-score and a p-value. Okay, so just to keep going, we are still stating our conclusion. Okay, I'm not done with that step in the process. All right, so this means that right now we've got our p-value and we're comparing, so we compare the p-value, which is something the calculator gives us, to the alpha level, okay, which is something that either is given in the wording or we find by the complement of the confidence level. All right. So remember that this could also be referred to as our significance level. That's totally fine. And once we have these two numbers, we actually have to compare the values directly. Okay, so we have two choices. Number one, if the p-value is less than the alpha level, okay, so literally smaller than. So this means it's a small p-value. Okay, very, very tiny. These are all decimals. So we're talking decimals with several zeros in front for the p-value, maybe even scientific notation, okay? Then we reject the null hypothesis, okay? So if the p-value is less than the alpha level, we get to reject the null. Okay, this is significant. All right, so p-value being less than alpha means we reject the null, and then we get to conclude there is enough evidence, ... and then we get to write like to show change. Okay, in whatever context that means in our problem. All right, and this is what we want. We want to reject the null, okay? We want to show a change. So that's why the wording for this other option is so, we'll call it obnoxious, okay? If your p-value is greater than or equal to your alpha level, okay, so these are bigger p-values, right? These are really tiny numbers, and these are now much larger. If my p-value happens to be larger than my alpha level, then there is no way we can actually accept the null, okay? So we actually are forced to say we fail to reject the null hypothesis. So we fail to reject the null if the p-value is greater than or equal to the alpha level. And unfortunately, what we do is we basically negate this statement, right? So we never go back and say, yeah, the null was true. Because remember, guys, over here in our first set of notes, we actually know that we have information about a change, and we're trying to show that the change happened. Okay? So we're never going to go and lie and say the null was actually true. We're going to say, well, we just don't have enough evidence to say that there was a change. Okay? So we're forced to use language similar to there is not enough evidence, ... And then to show, I still use the same language. Okay? I always refer to whether I am or am not able to show the change that happened. I actually never say, yeah, it's equal to the old population proportion, because I'm always trying to talk about what I was hoping to show, okay? So this can be a little bit tricky at the very end, but this is how we make any conclusion to a hypothesis test. And we actually write these conclusions out in words, okay? So one of the expectations I have is that we can write little sentences at the end of each one of these hypothesis tests. So that was a good amount of information. I have one more thing I want to comment on, and it's just a comment that I don't ever change the conditions for proportions, and then I'll create a video with some examples. So the last thing I want to note is that the 3 conditions for proportions, oops, I should spell it right, proportions, still apply. Okay? So I still need to check independence, randomization. The second condition was success, failure, and the third condition was the 10% condition. Okay, so a reminder, this was if random, then independent. This was at least 10 successes and failures. So we have to check if we've got at least 10 successes and at least 10 failures. And then finally, N must be less than 10% of the population. Okay, those are all the notes for chapter 17. I'll go ahead and scan these and add them underneath the video so you have a document that contains all the notes as well as a video for it. The next video I'll create are a few examples for hypothesis testing for proportions.